Welcome to AI Decoded, the podcast that demystifies artificial intelligence and explores how it's transforming our world. And before we begin, here's something that makes this show truly unique. AI Decoded is the first podcast about artificial intelligence created by supervised AI. That's right. Every episode is written, structured, and produced with the help of AI, guided by human experts, to bring you not just the most up-to-date and relevant content, but insights that are accurate and focused on what you really need to understand. I'm Emma Clark, and I'm thrilled to be your guide on this journey into one of the most transformative and fascinating technologies of our time.
And I'm Michael Reynolds. Whether you're an AI enthusiast, a tech professional looking to stay ahead of the curve, or just someone curious about all the buzz around AI, this podcast is for you. We're here to break down the complexity, demystify the jargon, and show you how AI is changing the world, one innovation at a time.
Our goal is simple: to make AI accessible and relatable for everyone. You don't need a PhD in computer science to understand this podcast. We'll take you through the basics, walk you through real-world applications, and explore what AI means for your career, your business, and your daily life. AI is often seen as a game-changing technology, but the reality is that it isn't foolproof. AI failures have led to financial losses, reputational damage, and even loss of human lives. Today, we're diving deep into the most infamous AI failures, their causes, and what businesses can learn from them.
That's right. AI is only as good as its data, training, and human oversight. When any part of that system fails, whether it's biased training data, real-world unpredictability, or poor model design, the results can be disastrous.
According to a 2024 Gartner report, 85% of AI projects fail due to poor data quality, misalignment with business needs, or lack of explainability. That means that most AI implementations don't deliver the expected results. Let's break down why AI fails and explore some of the biggest real-world disasters caused by AI. So let's get into it, because while AI has this dazzling, futuristic image, the truth is it can and does fail in very human ways. We're talking about mistakes that aren't just theoretical. They've played out in the real world with serious consequences.
Exactly. From self-driving cars that couldn't recognize pedestrians, to hiring algorithms that quietly perpetuated discrimination, the failures we're about to explore didn't come from evil AI. They came from poor design, bad data, and missing oversight.
Buckle up, because we're starting with a look at self-driving cars, where machine learning meets the unpredictability of the open road. And spoiler alert, it hasn't gone smoothly. So let's go back to autonomous vehicles for a second. Michael, what actually makes these cars smart? I think people assume it's like magic, but clearly it's not.
Far from magic. At the core of autonomous vehicles are deep learning models, primarily convolutional neural networks that interpret camera feeds, LiDAR inputs, and sensor data to detect objects, predict behavior, and make decisions in real time. But here's the catch. These models are heavily dependent on their training data.
So if they haven't seen something before, they're flying blind?
Exactly. That's called the edge case problem. For example, in Uber's 2018 fatal crash, the system failed to classify a pedestrian walking a bicycle across an unmarked street at night. It wasn't that the car didn't see her, it saw something. But it couldn't decide what that something was fast enough to act, and that's the scary part. It was a classification delay.
So it was like pedestrian, object, bicycle, don't know, too late.
Pretty much. And because Uber had disabled emergency braking for smoother test rides, the backup safety net failed too. The system's object detection stack hadn't been trained adequately for unexpected human motion outside of a crosswalk.
And that ties into Tesla's issues too, right? The AI just doesn't handle the unpredictable well.
Correct. Tesla's autopilot relies on neural networks trained on millions of real-world driving scenarios. But even with all that data, it still misinterprets things like stationary trucks or improperly marked lanes. In several cases, the system failed to detect stopped emergency vehicles on highways, resulting in fatal crashes.
Which is wild, because Tesla drivers often think autopilot means hands-off. But the system isn't autonomous. It's assisted driving with limitations.
Exactly. It's level 2 autonomy, not level 5. The technology's branding often outpaces its actual readiness.
Let's talk about hiring. Amazon's resume screening AI is now infamous. But that wasn't just a PR issue. It was a design failure, right?
Yes, it's a classic case of bias in training data. The model was trained on 10 years of Amazon's historical hiring decisions, which reflected existing gender imbalances in tech. So the AI essentially learned that male candidates were more likely to be successful.
And then punished resumes that hinted at being female, like mentioning women's chess club or all-female coding boot camps.
Exactly. This is known as proxy bias, where the system uses seemingly neutral indicators that correlate with protected attributes. Amazon shut it down in 2018, but the lesson is clear. AI doesn't eliminate bias, it automates it at scale.
And this isn't limited to resumes. I've seen reports of AI interview tools analyzing voice, facial expressions, even eye movement. How can we trust that?
We can't, not without serious validation. Tools like HireVue have faced criticism for using facial analysis to assess candidates' emotional stability or enthusiasm. But those systems often lack explainability and transparency. Not to mention, they may fail for neurodiverse or non-native speakers.
Michael, if there's one area where AI failures can have life-altering consequences, it's law enforcement. We're not just talking about financial loss or bad recommendations. These systems impact liberty, justice, even safety.
Exactly. Let's start with facial recognition, one of the most controversial uses of AI in public safety. These systems promise faster suspect identification, but the reality has been riddled with bias and wrongful arrests.
Didn't several people get falsely arrested because of facial recognition errors?
Yes. One of the most cited cases is Robert Williams, a black man in Michigan who was arrested in front of his family in 2020. The police relied on a facial recognition match from store surveillance footage, but it was a false match. He spent 30 hours in jail before they admitted the mistake. Some of the root causes are models trained on biased datasets with underrepresentation of non-white faces, higher false positive rates for Black, Latino, and Asian individuals, over-reliance on AI matches without human verification.
And this isn't just a one-off?
Not at all. Studies by MIT and the ACLU have shown that some commercial facial recognition systems have error rates over 35% for darker-skinned women, compared to under 1% for white men.
That's a massive discrepancy. It turns AI from a helpful tool into a source of injustice.
And that's why several cities, including San Francisco, Boston, and Portland, have now banned government use of facial recognition entirely. Even big tech players like IBM and Microsoft pulled out of the law enforcement market.
All right, let's pivot to something unexpected. Real estate. I remember Zillow tried to flip houses using AI. What happened there?
Zillow built an AI-powered home buying program called Zillow Offers. The idea was, use predictive algorithms to assess property values, buy low and sell high.
Flipping houses, but with machine learning.
Exactly. But during 2020 to 2021, the housing market got chaotic. Zillow's AI overestimated property values in several markets and bought thousands of homes at inflated prices.
Then couldn't sell them. Ouch!
They lost over $500 million and shut down the program in 2021. The problem? The AI couldn't adapt quickly to changing market conditions. It was trained on historical price trends and missed the volatility caused by COVID-era shifts.
So we're back to the same theme. AI trained on the past can fail in the future.
Bingo.
Let's head into the healthcare space, probably the most high-stakes use case of all. If AI fails here, we're not just talking about money or mistakes. We're talking about lives.
Absolutely. AI in healthcare is often built using supervised learning. Models trained on labeled medical data to predict diagnoses, recommend treatments, or interpret scans. But these models don't generalize well unless they're trained on diverse, real-world data, which is exactly where IBM Watson fell short.
Watson was supposed to be the crown jewel of medical AI, right?
It was. IBM promised Watson would revolutionize oncology by reading thousands of medical journals and helping doctors choose treatments. But in practice, Watson relied on synthetic training data, hypothetical cases created by doctors rather than actual patient histories.
So it could ace the textbook test, but flunked in the ER.
Exactly. In one case, Watson recommended a treatment that could have killed a cancer patient due to drug contraindications. That's a contextual understanding failure. The AI didn't recognize complex, overlapping conditions that didn't match its training examples.
And wasn't there another player in the medical AI space that had a very different trajectory? DeepMind?
Yes, Google DeepMind took a more focused approach. Their AI for eye disease diagnosis trained on nearly 15,000 real retinal scans from Moorfields Eye Hospital in London. It outperformed human doctors in identifying over 50 retinal conditions.
So why didn't it fail?
Because of three things. 1. Real-world data. 2. Clinical collaboration. And 3. Explainability. Their AI didn't just output a diagnosis, it provided a visual map of the decision, helping doctors understand why it reached its conclusion.
So it didn't replace the doctors. It worked with them.
Exactly. The failure of Watson and the success of DeepMind show that AI in medicine must be interpretable, collaborative, and clinically validated.
Michael, we've talked a lot about high-stakes failures, autonomous vehicles, healthcare, hiring, but some of the most visible AI missteps happen in places we interact with daily. Shopping, watching videos, even getting ads online.
Exactly, and while these don't always risk lives, they do affect trust, privacy, brand reputation, and billions of dollars. Let's start with one of the most infamous failures in retail AI, Target's pregnancy prediction algorithm.
Oh, right. This is the one where a teenager's father found out she was pregnant because Target started sending her baby product coupons, right?
That's the one. Target used a predictive analytics model based on customer behavior, purchases of unscented lotion, vitamin supplements, cotton balls, and so on, to estimate whether a customer was likely pregnant. The algorithm was technically accurate, but socially tone-deaf. The company failed to anticipate the backlash of making such private inferences so visible. The outcome was a public relations disaster and media frenzy. Target had to restructure how promotions were delivered to make predictions less obvious. The case became a cautionary tale in data privacy and responsible inference.
So AI didn't make a mistake on the math, it just skipped the human context.
Right, and this kind of blind spot happens often in AI-powered recommendation systems. A major example, YouTube's content algorithm.
Oh yeah, I've heard YouTube has struggled with misinformation and radicalization in its recommendations.
Exactly. YouTube's AI was optimized for one metric, watch time. The longer users stayed on the platform, the better the algorithm thought it was doing. But that goal created an algorithmic feedback loop. The system learned that controversial, extreme, or conspiracy-laden content often kept people engaged longer, so it began pushing more of it. The real-world consequences were the spread of misinformation, e.g. flat Earth, anti-vaccine theories, the radicalization pathways for fringe ideologies, and ongoing regulatory and societal pressure on platform accountability.
And because the algorithm is a black box, no one could explain why it was recommending what it was recommending.
Exactly. Even the engineers didn't always understand. This highlights the risk of optimization without guardrails, a core theme in many AI failures.
Michael, if there's one AI challenge that hits billions of people every day, it's content moderation. We're all on platforms, Instagram, YouTube, TikTok, and AI is behind what we see, what gets removed, and what goes viral.
Absolutely. And while moderation at scale requires automation, the systems often fail in both directions. They either miss harmful content or remove things that should have stayed up. Let's start with false positives, when content is incorrectly flagged.
Right? Like when someone posts about breast cancer awareness and the AI censors it for nudity.
Exactly. Facebook and Instagram's content moderation AIs have a history of flagging educational or artistic content that includes skin tone, medical language, or cultural symbols. The issue? These models were trained to prioritize surface-level visual cues over nuanced context. In 2022, Instagram removed posts featuring indigenous ceremonial wear, mistakenly tagging them as violence-related. Facebook's AI wrongly flagged cancer survivor posts as sexual content due to skin exposure in medical photos. Artists reporting their work removed despite educational or historical value.
So people lose their voices, especially in health, activism, and marginalized communities, because AI doesn't get context.
And that's the key weakness. AI doesn't understand meaning. It learns statistical patterns, not intent, which becomes even more dangerous when we talk about misinformation.
Let's talk about that. Misinformation spreads faster than ever. And ironically, sometimes the AI is helping it go viral.
Yes. Studies from MIT and the University of Washington found that AI-powered recommendation systems tend to amplify polarizing content because outrage, fear, and shock increase engagement. Platforms optimized for attention, like YouTube and TikTok, unintentionally promote conspiracy theories and pseudoscience. During the pandemic, TikTok's AI-driven algorithms pushed anti-vaccine videos, fake cures, and conspiracy content. The Center for Countering Digital Hate found that users as young as 13 were exposed to misinformation within minutes. TikTok's AI failed to detect videos that used coded language, misspellings, or symbols to bypass detection.
And what about when platforms try to fix it? Don't they just end up censoring legitimate stuff too?
Exactly. That's the false negative, false positive trade-off. When platforms dial up aggression to catch harmful content, they also sweep up satire, journalism, or political speech. And without human review, there's no appeal. During the 2022 elections, Twitter's AI mistakenly flagged dozens of verified political candidates' tweets as misinformation. Several official accounts were temporarily suspended with no explanation. The takedowns occurred during active campaign weeks, sparking backlash and claims of censorship.
So we've got three major issues: censorship without explanation, failure to catch real harm, and algorithms that reward shock, not truth.
Exactly. And all of this is worsened by the black box nature of these models. Platforms rarely explain how moderation decisions are made or offer ways to challenge them. And the line between policy enforcement and algorithmic error is blurry.
And it's global too, right? These systems were trained mostly in English-speaking contexts. So what happens in other languages?
Great point. In places like Myanmar and Ethiopia, Facebook admitted its AI moderation systems couldn't adequately process local languages, allowing hate speech and calls to violence to spread unchecked. In 2021, whistleblower Frances Haugen revealed internal documents showing Facebook was aware and underinvesting in multilingual moderation. In Myanmar, unchecked hate speech on Facebook was linked to offline violence and incitement during the Rohingya crisis. In India and Ethiopia, AI moderation failed to detect hate campaigns due to lack of regional language support.
Let's talk about money, because finance is one of the first places where AI went mainstream. But in such a high-stakes industry, even a tiny misstep can turn into a billion-dollar disaster.
Exactly. Financial AI operates at extreme speeds. Milliseconds can mean millions. That makes it powerful but also fragile. And while the old flash crash stories are still relevant, today's challenges are even more complex.
Like what? What are the modern AI pitfalls we're seeing now?
Let's start with AI in lending. Platforms like Zest AI and Upstart use machine learning models to automate credit risk assessments. The goal is to move beyond traditional FICO scores by analyzing alternative data, bank transaction histories, utility payments, even education and employment patterns.
Sounds smart in theory. More data, more nuance. But where's the catch?
The catch is explainability. These models often function as black boxes, and regulators are asking, why was this person denied a loan? Under the Equal Credit Opportunity Act, lenders must provide clear reasons for denial, and with AI, that's often a challenge.
So you've got smarter decisions, but less transparency?
Exactly. Upstart even had to pause parts of its model deployment to better align with fairness metrics and to prevent potential disparate impact, where an algorithm indirectly harms protected groups.
What about algorithmic trading? That's still the Wild West, right?
It's more like a Formula One race now. Firms like JP Morgan use AI engines like LOXM to optimize large order executions, minimizing market impact by slicing trades over time and adapting to real-time liquidity.
So the AI figures out how to hide your trading footprint?
Exactly, but the risk is still real. These models can trigger feedback loops if too many firms use similar algorithms. That's why top players like Citadel and Two Sigma have multi-layered AI systems with real-time monitoring, human-in-the-loop checkpoints, and aggressive scenario testing.
So the modern hedge fund stack isn't just let the AI run, it's let the AI run safely.
Exactly. Most quant funds today operate in what we call a human-AI hybrid loop, where humans define the strategy and constraints, while AI executes and adapts within guardrails.
I can't help thinking of Robinhood during the GameStop mania. That wasn't a trading algorithm failure per se, but AI still played a role, didn't it?
Absolutely. Robinhood's recommendation and engagement algorithms prioritized content that increased user activity. In 2021, That contributed to the meme stock explosion, with retail investors making emotionally charged trades fueled by social sentiment and virality.
So the AI wasn't trading, but it was influencing who traded, when, and why.
Right. And this highlights a subtle but growing danger in finance. Engagement-optimized AI influencing financial behavior. It's not just about execution anymore, it's about attention manipulation.
Which is dangerous when people are risking their savings based on push notifications and gamified trading prompts.
Exactly. The SEC is now investigating how AI-powered nudges might cross ethical lines in fintech. It's a new kind of risk, behavioral distortion caused by algorithmic influence.
So what are regulators doing to keep up?
We're starting to see movement. In the US, the SEC, Stock Exchange Commission, is exploring new rules that would require AI systems used in investment platforms to be auditable and explainable. They're also looking at restrictions on conflicted AI models, where the platform profits when users take more risk.
And globally?
In the UK, the FCA, Financial Conduct Authority, is piloting sandbox testing for AI systems before full-scale deployment. And the Bank of International Settlements is pushing for global AI audit frameworks, especially for cross-border lending and trading systems.
So we're not there yet, but we're at least acknowledging that AI in finance needs its own playbook.
Exactly. The key is balancing innovation with accountability. Because when money moves at machine speed, the room for error shrinks, and the consequences scale.
All right, this one feels like a movie plot, but it's happening in real time. AI isn't just helping us defend against cyber threats. It's also being used to launch them.
That's right. We're in a full-blown AI arms race, where cyber criminals and defenders are both deploying machine learning tools at scale. And the stakes? National security, financial markets, critical infrastructure.
Okay, set the scene. How is AI actually being used offensively in the cyber world right now?
Let's start with a chilling real case from early 2024. In Hong Kong, a finance employee at a multinational firm joined a video call with what appeared to be their CFO and several colleagues. They transferred $25 million, but none of those people were real.
Wait, what?
The attackers used real-time deepfake video and voice cloning to simulate an entire conference call. The victim later said the deepfakes were completely convincing, right down to facial expressions and tone of voice.
That is next level terrifying. This isn't just spam anymore, it's synthetic reality.
Exactly. We're now seeing tools like Worm GPT and Fraud GPT, uncensored versions of language models trained specifically for phishing, malware generation, and scam automation.
Wait, so these are like ChatGPT, but evil?
Pretty much. These models are available on the dark web and are part of what's called Phishing as a Service platforms, or FAS. For a monthly fee, criminals can access AI that writes spear phishing emails, generates malicious code, or automates deepfake voice attacks.
So you don't even need to be a hacker anymore, just a subscriber.
Exactly, and nation-state actors are in on it too. North Korean and Russian-linked groups are using large language models to craft more believable social engineering attacks, fake job offers, and even to generate malware code on the fly.
So what's fighting back? I mean, it's not just humans versus robots, right?
Thankfully, no. The defenders are getting smarter too. Microsoft launched Security Copilot in 2023, an AI-powered platform that combines OpenAI's models with Microsoft Threat Intelligence to help security teams triage, investigate, and respond to incidents faster.
So it's like a digital security analyst that never sleeps?
Exactly, and Google has Chronicle AI, which uses large-scale anomaly detection and threat graph modeling to identify suspicious patterns across cloud environments and endpoints.
But can these models spot deepfakes and adversarial attacks?
That's where adversarial training and AI red teaming come in. Companies are actively stress testing their AI models to make them more robust. Some are even using federated learning, where security models are trained across decentralized devices to detect threats without centralizing sensitive data.
I'm guessing the explainability problem pops up here too?
Absolutely. In cybersecurity, false positives are a big deal. If your AI flags a legitimate process as a threat, it can shut down systems, disrupt operations, or block users. But if it misses something subtle, you could get breached.
So we need to trust these systems, but also understand their logic?
Exactly. That's why XAI, explainable AI, is becoming essential in SOCs, Security Operations Centers. Analysts need to understand why a model flagged an activity as anomalous, especially if it triggers automated responses like quarantining files or blocking access.
So what's next? Are we just going to keep escalating until AI takes over the whole cyber battlefield?
Not quite. The future lies in hybrid AI-human teams, where AI handles the scale and speed, but humans handle the judgment. Think of it as machine intuition with human ethics.
Sounds like the only way forward in a world where the attacker and the defender both have AI on their side. What about human-in-the-loop AI? That seems to come up a lot, especially in AI ethics panels.
It's a game changer. Instead of fully automating a task, human-in-the-loop systems combine AI efficiency with human judgment. The AI makes a recommendation, but a person reviews it, edits it, or vetoes it.
So we're not just blindly trusting the machine, we're collaborating with it.
Exactly. And it's especially powerful in situations where context, nuance, or empathy matter. For instance, in recruiting, tools like Eightfold.ai can surface candidates, but HR professionals still make the final call.
Or in medicine, AI helps flag anomalies in scans, but radiologists make the diagnosis.
Right, and in customer support, platforms like Ada or Zendesk AI handle routine queries, while humans step in for complex or emotional issues.
Let's talk about the hottest space right now, generative AI. Everyone's using tools like ChatGPT or Midjourney, but how do we avoid repeating past mistakes?
That's the challenge. Generative models like GPT-4, Claude, and Gemini are incredibly powerful, but also prone to hallucinations, generating false information that sounds correct.
So they sound confident, even when they're wrong?
Exactly. That's why companies are investing in fine-tuning and domain-specific training. For example, Hippocratic AI is developing large language models trained specifically on validated medical literature to avoid dangerous outputs.
So generative AI becomes more reliable by narrowing its focus?
Yes, the future is in verticalized AI tools purpose-built for law, medicine, finance, or manufacturing, where the stakes are too high for error.
And is there work happening around making these models fact-check themselves?
Yes, Meta's Toolformer and OpenAI's Retriever, augmented generation RAG frameworks, integrate external knowledge bases so models can verify claims in real time before generating responses.
Let's talk policy. Governments seem to be waking up to the risks. Are we finally going to get meaningful regulation?
We're getting there. The EU's AI Act is the most comprehensive effort so far. It classifies AI systems by risk level, unacceptable, high risk, and low risk, and mandates testing, transparency, and oversight for high-risk applications.
So facial recognition in public? That's considered high risk?
Exactly, and companies will need to prove that their models are safe, fair, and explainable before going to market.
What about in the US?
More fragmented, but the White House blueprint for an AI Bill of Rights lays out principles around safety, privacy, and algorithmic fairness. Agencies like the FTC are also cracking down on deceptive AI use, especially in advertising and finance.
So we're starting to see the scaffolding for accountability.
Yes, and that's long overdue. For AI to be safe, we need regulatory frameworks, industry standards, and public transparency all working together.
So bottom line, is AI going to get safer, smarter, more ethical?
It has to. The trend is toward responsible AI designed with fairness, privacy, and robustness in mind from the ground up. That includes stress testing models using synthetic data for edge cases and developing adaptive safety mechanisms.
Kind of like how aircraft are stress tested before ever carrying passengers?
Exactly. AI will go through safety validation pipelines, testing how it behaves under pressure in edge cases or when confronted with adversarial attacks.
And what about collaboration between countries, companies, researchers?
That's another piece. Initiatives like the Partnership on AI, OECD's, AI Principles, and OpenAI's Preparedness Team are all working toward global cooperation on safe deployment. We're even seeing proposals for international AI watchdogs, similar to how nuclear materials are monitored globally.
Wow. So we've gone from AI as magic to AI as infrastructure, something that requires safety codes, human supervision, and shared responsibility.
Beautifully said. AI's future isn't just about more power. It's about more responsibility and resilience. And if we get that right, we can unlock the full promise of this technology.
All right, let's bring this full circle. We've unpacked some of the biggest AI breakdowns across industries, from life-threatening medical misdiagnoses to billion-dollar trading errors. What are the biggest lessons?
Let's distill it down. First, AI amplifies what it's trained on, whether it's biased hiring data, flawed medical records, or financial volatility. Garbage in, garbage out. Automation isn't intelligence, and machine speed without human oversight can spiral into chaos. Context matters. Models that work in labs often fall apart in the messy, unpredictable real world.
And we also saw how explainability is non-negotiable in fields like law or healthcare. If we don't know why an AI made a decision, we shouldn't trust it. Edge cases aren't optional. Models need to be tested against rare and extreme scenarios, not just the average case. Adversarial attacks are real, and AI systems are still far too easy to manipulate if left unchecked.
Exactly, but we're also seeing serious progress. Human-in-the-loop models are catching on. Explainable AI tools are gaining traction. Governments and companies are finally getting serious about regulation. And domain-specific, safer generative AI is becoming the norm.
This episode wasn't just about fear, it's about awareness. AI doesn't have to be flawless to be useful, but it does need to be designed with care, tested with rigor, and deployed with humility.
Totally agree. We're not saying AI is dangerous. We're saying AI without foresight, accountability, and ethical design can be dangerous. The good news? We're learning from the wreckage.
And hopefully, as we move forward, companies, developers, and governments will treat AI like the critical infrastructure it is, not just as a shiny toy or a quick win.
Because when it's done right, AI can improve lives, save time, reduce errors, and unlock progress we've never seen before. But only if we build it and govern it wisely.
If you enjoyed today's episode, make sure to subscribe so you never miss an update. And if you found value in our discussion, share it with friends, colleagues, or anyone curious about the impact of AI. Spreading awareness is one of the most powerful ways to create a better understanding of this transformative technology.
Until next time, keep exploring, keep questioning, and keep decoding AI. This is Michael Reynolds.
And Emma Clark, signing off from AI Decoded. See you next time.